Guys, in this video we're going to discuss about the smart contract that is being developed for decentralized applications, decentralized messenger, right? So without further delay, let's move on to the video and discuss what are the functions that are present in the smart contract and how it works. And yeah, let's move on to the video. Okay, here we go. This one, right? Okay, fine. So as usual, the first line means the license identifier XPDX license identifier. This is unknown license, so it can be MIT. I personally go with the MIT because this is open source. Anyone can use it. And the second line means we are using 0.8.9 or greater than 0.8.9 solidity version for compiling this smart contract. And as I said before, we are also dealing with the NFTs, uh, right? In order to get into particular uh, messenger group, then you need a particular specific NFT, so which should be minted before entering into the group. So that's the ideology for it. So we are using the Open Zeppelin library for extracting ERC 721 contract, right? And we are inheriting the ERC 721 contract from our contract, and we are defining few state variables, right? And we are modeling the channel. So this channel contains of three variables. One is the ID, which is nothing but the channel ID, the name of the ID, and the cost required in order to join the channel, not to create the channel, in order to join the channel. And we have the modifier, which is a custom modifier, which means that only the user, so I mean only the owner can access that particular functions when you apply this modifier to a function. We'll discuss about this, right? And we have few mapping, okay, which is used to store the modeled channels. And here is the main thing. We have to pass the underscore name and as well as underscore symbol to the EOC 721 contract, which we are inheriting from the Open Zeppelin library, right? And also we are defining the owner. So at the starting here you can see the state variable for the owner, and we are just initializing the owner with the global variable message.sender, right? And here is the main function, which is create channel function, so which takes two parameters. One is name as well as the cost. So first thing is we have to model it, right? Model the channel before we are going to store it in using the mapping. So this modeling, as I said before, here it is being modeled, so it takes three parameters, I mean three variables. So we're getting two variables from the user, and one variable we are going to increment it whenever we're calling this function. And by this way we're creating a channel, and we're going to store the channel with the help of the mapping. Okay, here the UN 256 is nothing but the total supply, total channel. So that's what it means. And this function is for minting the NFTs, and it considers few required conditions, right? The ID should not be equal to 0, and it should be greater than or equal to total channels, right? And it should be, I mean, this NFT should not be owned by the user who is going to mint it, right? That's what this line means. And this is nothing but the message that value should be greater than or equal to the cost which is required to join the channel, right? And we are incrementing this one, right? And we are using the safe mint function from EOC 721 in order to mint the NFT. And this get channel is used to get the channel by passing the ID, and this is nothing but the mapping, as I said before. Here you can see, here's the mapping. We're passing the ID and getting the channel. So channel is nothing but the structure which contains these three variables, right? And this function is to withdraw the Ethereum from the smart contract to the owner's address. So this is the most popular way of doing it. So we have some other ways also, like using the transfer functions from ERC 721 contract, but most of the developers prefer this, so I had to go with it. So once after doing it, we're just running the npx hard node, okay, running the local node, and we're going to deploy it with the hard Here you can see npx hard hat run scripts deploy.js, So we have the deploy script, which we are going to speak in the next upcoming videos, which is very similar to testing the smart contracts. And we're going to deploy this in the local host, which is a test net. It's not a main net. So whenever you're going to deploy the smart contract to the main net, you have to pick the gas fee. So this is for the development purpose. So that's why I'm deploying it in the overhead test net. And here's the address. Okay, here's the address for the smart contract which is being deployed. So that's it. So I think it's very easy. Like there is only few important functionalities, like creating an channel and storing the channel. Okay, and also we're going to mint the NFT in order to get into a channel. And finally we're going to withdraw the Ethereum from the smart contract to the owner's address, owner's wallet. So that's it. That's pretty much it. So everything is done. We have deployed it. So the first stage of our project is being done. So the second stage is testing the smart contract, okay, using the JavaScript with the Mocha as well as the Chaya session library tools. And maybe if possible, let's do a video on it, right? So thanks for watching. If you have any doubts regarding this topic, regarding the smart contract for this project, so leave in the comment section. I will just clear it off. So thanks for watching. See you on the next video. Until then, this is Balamurgan signing off. Peace.